Hey everyone, can you all hear me?
Yes, sir.
All right, yeah. Sorry for the technical glitch. Dr. Kende, Uweye, and I'll be sharing this technical session to be of the International Conference on Machine and Computing Technology for Sustainable Development with Dr. Charlene Puri. I don't know if Dr. Charlene Puri is online. So we have 8 papers for this particular session. Um, the very first paper will be on multimodal, stochastic, and clinically optimized approach to predicting in-hospital mortality for asthma patients by Paritosh Dwivedi. So I don't know if Paritosh is online to actually start this presentation.
Yes, sir. I'm online.
All right, yeah, the floor is yours. Just over to you.
Okay.
So you have 12 minutes for this presentation, and then yeah, there'll be 3 minutes for questions and answers. Thanks very
Okay.
much.
Okay, sir. Is my screen visible?
Yes.
Okay. So, good morning, everyone. My name is Paritosh Dwivedi from the School of Computer Science and Engineering at VIT Vellore, India. Today, I will be presenting our work titled A Multimodal, Stochastic, and Clinically Optimized Approach to Predicting In-Hospital Mortality for Asthma Patients. This research was conducted under the supervision of Dr. Swati Jamdala Narayanan. And so, asthma is a globally significant respiratory condition. And while hospital mortality is relatively rare, it is extremely preventable with effective early warning systems. But however, current predictive models often rely on simple scoring systems or rather static clinical snapshots. So, our work addresses this gap by developing a generalizable mortality prediction system that integrates multimodal data, models the dynamic physiological changes, and is optimized for clinical utility, specifically the F1 score, rather than a purely statistical AUC. So the overall goal here is to build a model that is both accurate and clinically actionable across different hospital systems. The existing research primarily focuses on traditional scoring systems like SOFA and Apache, machine learning models that work well on one dataset. But there are three major gaps there. Firstly, most models treat patients' data as static, ignoring the temporal evolution of vitals and labs. And secondly, cross-hospital validation is rarely performed, so real-world generalizability remains weak. And lastly, the models optimize for AUC, which doesn't translate well into clinical decisions, making where false negatives are dangerous. And so this motivates our shift towards neural SDEs, multimodal integration, and clinical F1 optimization. We define the core problem as follows. The current asthma mortality models lack generalizability, treat data as static, and optimize the wrong metrics. We explore four key research questions here. Can multimodal temporally aware system outperform existing baselines? Does optimizing for F1 score instead of the AOC improve the clinical value? Does the model remain robust when tested on external hospital data? And finally, what is the economic value of deploying such a system? And so for this, we use two major publicly available ICU datasets, Mimic 3 from Beth Israel Hospital, a single center dataset spanning from 2001 to 2012, and EICU, that's a multi-institutional dataset from the time period of 2014-15, covering over 200 hospitals. And so the mimicry is used for model development, while EICU is used exclusively for external validation. Our methodology combines five complementary data streams: structured EHR data, clinical interventions, clinical BERT embeddings, statistical time series features, and neural SD trajectory embeddings. And so the neural SDs are key here. They capture the continuous time stochastic physiological dynamics, overcoming the limitations of discrete sampling. Here you can see the full pipeline. The neural SD generates a 64-dimensional trajectory embedding, which effectively summarizes temporal behavior. These embeddings are combined with clinical BERT features from unstructured nodes and TS-fresh statistical features from vitals. And so the final feature vector is fed into an XGBoost model optimized specifically for the clinical balance between precision and recall. The final classifier is the XGBoost model, trained using weighted cross entropy loss, tuned via Optuna with over 200 trials. And so we prioritized F1 score during training because mortality prediction is highly imbalanced and false negatives are clinically dangerous. And so the post calibration was done using Hosmer, Lemichaud test and Breyer score, ensuring statistical reliability. The model achieves excellent performance when validated on the external EICU dataset with an AOC of 96, F1 of 74, recall 73, and a precision of 61. This shows that the model not only predicts mortality accurately, but it also generalizable across unrelatable hospital systems, which is critical for real world deployment. And so we also evaluated the cost effectiveness using the Markov based health economics. And so these savings come primarily from better ICU triage, targeted intervention, and reduced complications. Our major contributions are a novel integration of neural SDs, clinical BERT TS Fresh, and F1 optimized learning. Successful cross-hospital validation, overcoming limitations of prior studies. A detailed economic justification for deployment. And lastly, sharp interpretability, showing that the model adapts to different hospital populations. And so to conclude, we present a clinically optimized multimodal model with strong cross-institutional performance. The model is both statistically powerful and economically efficient. For future work, we plan to conduct prospective clinical validation, expand to geographically diverse datasets, and integrate the model into real-time hospital workflows. Thank you.
Yeah, thank you, Paritosh, for that presentation. Um, I was wondering if there's anyone in the room who wants to ask Paritosh any question about his work.
Am I audible?
Yes, ma'am.
Yeah, thank you. So, your topic was a multimodal, stochastic, and clinically optimized approach to predicting in hospital mortality for asthma patients, right?
Yes, ma'am. Right.
So, yeah, I want to ask what challenges did you face regarding missing or noisy hospital data?
And so mostly the main challenge primarily was to get the data set because since hospitals usually keep this information confidential, to acquire these data sets, you need to have a certification, do certain courses for disclosure purposes. And then you have to apply for credential access for the data set. So that was the challenging part that I faced.
Okay, what was the dataset size?
The dataset size for there are two datasets used there. So the first dataset, the Mimic 3 was roughly 3.8 gigabytes, and for external validation, the EICU dataset was around 1 gigabyte.
Okay, so have you compared your work with existing research works? Like you have gone through literature review, right? So
Yes, ma'am.
how did you get your findings, and how did you compare your work with the other works?
And so mostly from the literature review, I noticed that for the training and testing, mostly the external validation is not done. And so mostly the researchers would primarily split the dataset into training and testing without external validation. And so for us, it was a key approach to ensure that the external validation works. And so it can be generalizable across different hospital systems and adapt accordingly.
Okay, okay, thank you so much.
Okay. Thank you, ma'am. Thank you, sir.
Yeah, thank you. Any other question? I think we still have two 2 minutes thereabouts. So I have one quick question for you. So you say you did optimize for F1 score, right? Is that correct?
Yes, sir.
Just curious as to how you did that. Yeah.
Okay.
I mean,
For
did
the
you did you
F1
define
score,
like an objective based on the F1 score and you try to optimize stuff based on that?
yes, sir. So I used F1 score instead of the AOC because for AOC, while it can be statistically significant, it doesn't give the clinically accurate findings or visibility to the doctors about the patients. And so the primary goal for the doctors would be to ensure that the resources, hospital resources, are being used correctly and prioritized accordingly. And so with the F1 score, it can be confirmed using the true generalizability, which is a major gap in existing literature.
All right. And I can assume, I want to assume that your training wasn't really end to end because I think at some point you used SG Boost classifier.
Yes, that's it.
Yeah. Why did you use SG Boost?
I used XGBoost because primarily for interpretability and stability. So when integrating my multimodal pipeline, the static, temporal, and the stochastic embeddings, the XGBoost provides better stability and less overfitting on the cross-institutional dataset. So that was my primary purpose for using the XGBoost classifier. Yes.
All right. Thanks very much.
Thank you.
Let's thank our speaker, Paritosh, for that presentation.
Excuse me, sir. Can you hear
Yeah.
me?
Yes, I can hear you.
Yes, sorry for the interruption, but please let me take a few moments to formally welcome everyone present here.
All right.
So, dear
No worries.
authors and invited guests, welcome to Technical Session 2B. My name is Dimahi Patel, and I will be the moderator for the session. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the International Conference on Machine and Computing Technologies for Sustainable Development, Manila, Philippines. The conference is being organized in a hybrid mode. The physical event was held yesterday in Manila, and the virtual event is being held through Zoom today and tomorrow, that is 12th and 13th December 2025. In this session, we have 8 presentations. Each presenter will be given 12 minutes for presentation and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. Before we start the session, I would like to introduce you all to the session chairs that we have with us. First, we have Dr. Kehinde Oe, sir. Sir is a senior data scientist at the National Engineering Laboratory, Scottish Enterprise Technology Park in the United Kingdom. His expertise spans machine learning, mining sector data from IoT devices, computational sustainability, privacy, and cybersecurity. He is committed to advancing data driven solutions that enhance innovation, security, and sustainable technological development. Welcome you, sir. If you have any few words that you want to say to the presenters aside from the previous ones, please let us know.
Not so much to say. I think I've already introduced the session
Yes.
earlier on. So yeah, there are 8 papers here, all focused on advancing computing technologies for sustainable development. So you're welcome again to this session, and yeah, hope you learn one or two things from this session and this conference overall. Yes.
Yes, thank you, sir. We also have with us Dr. Shalini Puri as our session chair. Dr. Shalini is an associate professor in the Department of Information Technology at Manipal University, Jaipur, India. With over 20 years of teaching experience and 11 years of research experience, she specializes in machine learning, artificial intelligence, and image processing. Dr. Puri has published 31 research papers and actively participates in national FDPs, workshops, and training programs. Her research interests include machine learning, image processing, pattern recognition, and artificial intelligence. Welcome, ma'am, and please share a few words you may have for the presenters today.
Yeah, thank you for the wonderful introduction. Thank you so much. So this is a very really good platform for the researchers and speakers to share their research. And I have gone through all the researched titles. They are really very good. So let's hope all goes well. All the best to all the presenters. Thank you. Thank you so much.
Thank you, ma'am. So, continuing with the presentations, I would like to call Vijaya Lakshmi ma'am to present her study on AI powered threat intelligence and defense, bridging gaps in modern cybersecurity. Vijaya Lakshmi ma'am, are you here with us? I repeat, is Vijaya Lakshmi ma'am or any of the co-authors present with us here today?
Maybe we can move to the next presenter if she's not around.
Yes, sir. Uzma Iqbal, ma'am, if you are here with us, please present your study on deep CNN-based framework for facial demographic prediction in smart systems.
Yes, I am here. Can I start my presentation?
Yes, ma'am.
Okay, thank you. Good morning. My name is Uzma Iqbal, and I am one of the author of the research paper titled Deep Convolutional Neural Network-Based Framework for Facial Demographic Prediction in Smart System. Alongside me are my co-authors Shehzad Ali, Usman Ali, Sajid, and Muhammad Mujib Akbar. There is a table of contents, introductions, related work, research objectives, methodology, dataset descriptions, performance analysis, comparisons with existing states of the art, conclusion, and future directions, references. Now let's look an introduction. In this research paper, we focus on predicting age and gender from facial images. This is important because it helps in areas like security and how we interact with technology. Different factors like how the face is turned, the light, and expressions can affect how accurate our predictions are. Over time, we used advanced methods to get better results, and our research use new techniques to improve accuracy even more. Research objectives. Our research objectives are to create a strong deep learning model that can accurately predict age and gender from facial images even in different conditions. We will use a special transformer based approach with conventional attentions to capture both big picture and details features. We will also test our model on public dataset like UTK faces to make sure it's accurate and can handle different angles and rotations. There is a summary of related work. This table summarizes previous studies and their techniques. It includes the year of the study, the models used, the dataset, the task performed, and the accuracy achieved. For example, one study from 2024 used a custom convolutional neural network on dataset like Adams and UTK faces for gender and age classification, achieving high accuracy. Another study from 2020 used multiple convolutional neural network architectures and dataset like UTK face and IBD wiki focusing on both gender classification and age estimation. This way we can see how different models and dataset compare in terms of performance. Related works on age and gender predictions. Now let's look at the recent studies on age and gender prediction. Many researchers use deep learning methods like convolutional neural networks and vision transformations. CNNs are great at picking up details features while transformers captures broader patterns. However, existing methods can struggle with different angles, lighting, and rotations. To fix these issues, researchers combine convolutional neural networks and attention mechanisms for better accuracy and performance. Our methodology has 5 main phases. First, for data collection, we used the UTK faces dataset, which has over 20K images, facial images labeled with age and gender. Next, in data preprocessing for resized, normalized, and augmenting the image, images to handle different poses, lighting, and rotations. Then for feature extractions, we combine transformer layers and convolutional attentions to capture both broad context and fine details. Finally, in model training, we use the Adam optimizers and measure the performance with mean absolute errors. Also used cross validation. Dataset description. Our dataset UTK faces includes over 20K facial images, each labeled with age, gender, and ethnicity. The age range is from 0 to 116 years. There are slightly more male images than female ones. The images also show a variety of light poses and ethnic backgrounds. On the right, have a chart that displays the age distributions for both gender, showing the real world diversity and some imbalance patterns. Performance evaluation. In next slide, we have performance evaluation metrics. Here is a clear prediction on this slide. We have the performance metrics for our gender classification model. Starting with the male class, the model achieved a version of 0.94, recall of 0.93, and F1 score of 0.93 based on 2500 samples. This indicates that the model is highly accurate in predicting male introits and maintain a good balance between Persians and recall. For the female class, the model reached a version of 0.92, recall of 0.94, and F1 score of 0.93 with 2242 samples. This shows that the model is equally strong in identifying female entries with slightly higher recall, meaning it captures more true positive.
Is that
In
the end
next
now?
slide. Yes. This slide shows how the model performs across different age groups. The 0 to 18 group has the strongest performance with an F1 score of 0.88, while the 19 to 30 group performs better with 75%. The model struggles more with the 31 to 45 and 46 to 60 groups, while F1 score dropped to around 0.65 to 0.66. Overall model accuracy is 75%, and both macro and weighted averages are around 0.75.
Hello, Miss Ushma, you're not audible. Hello, can you hear me?
Yes, ma'am. Uzma, ma'am, are you here with us? Are you still connected? She might be having some technical problems. Can we proceed with the next one till then?
Sure, ma'am.
Ranjini, ma'am, are you present with us? I repeat, Ranjini, ma'am. Rehan Patel. Or any of the co-authors of this paper? Sachin Divakar. Sachin, sir? Are you present here? Duong Bui? Duong ma'am?
So I think his man is back online. So.
Are you listening me? Hi.
Yes, ma'am. I believe you had some technical problems.
Okay, okay.
Can you
Now I am.
continue with the slide you left off last time?
Yeah. My last slide, conclusion and future direction. We introduced hybrid deep learning model that effectively combines transformer-based architecture with convolutional attentions. This approach captured both global and local facial features, resulting in improved accuracy and rotations invariance. Moving forward, we plan to test our model on larger and more diverse dataset to improve generalization. We also aim to incorporate fairness and privacy preserving techniques to address ethical concerns and ensure broader applicability in real world scenario. Thank you. Thank you all for your time and attention. I appreciate your interest and happy to answer any question you may have. Thank you.
Okay, thank you. Very nice presentation. I want to ask, how did you mitigate bias in demographic prediction? Hello.
Yeah, ma'am. Can you repeat your question, ma'am?
Yeah, how do you mitigate bias in demographic prediction?
Ma'am, in this paper, we predict two goals, basically two goals: age and gender with one model. Convolution will use one model convolutional neural network and so on.
So, any challenges or risk factors you faced during implementation or during applying this
We face,
approach?
ma'am, a lots of challenges like
Yes, yes, please.
classification problem and ma'am, are you listening, ma'am?
Yes, 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 please continue.
Yeah, we face a main two problems like a gender is a classification problem and age is a regression problem. So that's why to solve these problems, we are classified age groups, then predicts all, then do further process.
Okay, my next question is, have you, like, your system is robust enough to apply these data sets? How, like, can you, how can you imp further apply more techniques of machine learning, etc. in the future?
Ma'am, basically, we already developed a system like we integrate this model to real world, this model to um, a system based approach, ma'am, and that pick a picture and predict it. We want to also integrate with the real with the Android or any app that can helpful for security scenarios.
Okay, thank you.
Um, thanks for the
Okay.
presentation. Just one quick question from me. I mean, did you compare it with state-of-the-art methods in this
Yeah,
space?
ma'am. Yeah, sir.
Because I just didn't notice that in your slide yet. So one other question is, I mean, looking at the age range, right? The very first one is like 0 to 18. Do you really think that is useful in the real world? I mean, it looks broad to me, right? Imagine you're predicting someone's age and they say it's probably likely to be 0 to 18. That might just not be useful in some context. Is it something you factored? Do you consider reducing the age range at some point? Did you consider that?
Ma'am, sir, there is let's suppose not a some babies are month ages. So that's why these are all data sets are. Sir, I can't listen to your all questions as your voice are interrupted.
Did you hear me? Did you hear my question? Can you hear
Hello.
me? Can you hear me?
Ma'am,
Yeah,
are
but I
you
mean,
able to hear us?
Yes.
can you
Now.
hear me now? Can you hear me now?
Yeah.
All right, so I was just asking that, I mean, the age range seems to be very big to me. Like the very first age range was you showed us was between 0 to 18. I was just wondering if
Yeah.
that is really useful in the real world. I mean, imagine you're trying to predict someone's age now and you say, oh, 0 to 18. That person can be like a 1 year old, it can be a 17-year old. So just curious if you considered reducing the age range at some point.
Like sir, these age range 0 to 18. Your question about this question, sir.
Yeah, it looks really big to me. I'm just wondering about the practicality, if this can be used in the real world, if you understand what I mean.
Sir, it is easy as when model predicted, model is not showing like this age 0 to 18. No, model showing that it's 1 year and it's 2 year and so on.
All right, I think that's all from me. Thanks very much. Can we thank our speaker then? I think we can move to the next speaker.
Yes, sir. Next up, I would like to call Duong Bui ma'am to present a study on strategic pathways to sustainable competitive advantages, the role of digital leadership, innovation capacity, and digital skilling. Duong ma'am? Ma'am, please unmute your mic. I repeat, Duong Bui ma'am, please unmute your mic and start with the presentation. Can I call the next one, sir?
Yeah, sure, but I think she's online. Not quite sure why she's not responsive.
Em ơi, em vô đi.
Yes, sir.
Yes, she's June Boy. She's online right now. So please wait a moment. Kun Yin,
Yes, sir.
the call with her. Thank you.
Thank you.
Think we are probably behind schedule, so if there is any other author online, maybe it's better we just move.
No, sir,
Mr.
ma'am came just now. She'll be unmuting her mic now, in a moment. Your mic is muted.
Miss Yunbui, please unmute yourself.
Hi, everyone. Welcome to our presentation on statutory pathway to sustainable competitive advantage. This research explores a circular problem of digital leadership, digital scaling, innovation capacity. I am presenting on behalf of the author Yung Bui from Hùng Vương University and Cường Nguyễn from Industry University of Ho Chi Minh City, Vietnam. Let's start with the context. We are living in the era of conversion between sustainability and digital transformation. However, there is a gap in understanding. Digital leadership and platform digitization capacity have not been exposed clearly in the literature. The powerful effect of digital leadership on sustainable performance is an area that needs further research. Therefore, our research asks for key questions, focusing on the impact of digital leadership, innovation capacity, and digital transformation on creating sustainable competitive advantage. First, let's look at innovation capacity. Based on the result-based view, innovation resources are critical for process. Innovation capacity is optimal for gaining a competitive edge. A culture of risk-taking and creativity is fundamental. Organizations with strong innovation capacity can cope with market fluctuation and create sustainable competitive advantage. Next is digital leadership. Digital leadership emerged in 21st century as firms underwent digital transformation. Increased competitiveness create challenge for sustainability. Effective digital leadership is critical for team selection, process execution, and vision communication. Digital leaders articulate a clear digital vision and empower staff, fostering innovation and competitive advantage. However, these capabilities don't work in isolation. A central part of our model is the mediating role of digital transformation. First, we agree that high innovation capacity creates pressure for organizations to actually implement digital transformation. And second, rewarding digital leadership. Digital leadership boarding influences a company innovation performance through digital leadership and leadership interaction. And finally, the outcome, digital transformation improving resources utilization, opening a new avenues for long-term productivity and sustainable competitive advantage. Based on the relationship, we developed 6 hypotheses to test the direct and indirect effect between the variables. To test our model, we conducted a survey. We collected data from 178 managers across a diverse industry in Vietnam. We use SEM to ensure our result and reliable and valid. Now let's look at the key result. I am pleased to share that on hypothesis paths are statistically and significant. First, the most and notably path from digital leadership to digital transformation is the strongest, with beta of 0.570. This indicates that digital is a primary driver of transformation. And the second, both digital leadership and innovation capacity have direct positive impact on SCA. And third, digital transformation itself is valid as a creator of advantage. And finally, we found that digital skill positively moderate the impact of transformation with beta is 0.058, meaning a skill forwards imply the benefit of digital tool. We also analyze the mediation effect with bootstrapping. The result confirmed that indirect paths from leadership and innovation through digital transformation to SCA are significant. This leads us to conclusion that digital transformation effectively mediates the relationship between organization ascendant and competitive advantage. Furthermore, our Q-square value for digital and SCA are well above zero, indicating the model is strong predictive prevalence. So, what does it mean? First, digital leadership and innovation is crucial for guiding activity towards long-term robust properties. And the second, digital transformation is pivotal is integrate digital tool to promote continued develop and the moderating role of skill is the success of digital transformation is accrued in organization that process a digitally proficient workforce. In conclusion, this research contributes to the theory of digital leadership and sustainable competitive advantage. Our findings provide a basic of business leader to formulate better digital strategies. We acknowledge this study was conducted in Vietnam, which may limit generally. And also SEA is multifaceted and requires a diverse measurement. The future research should address the complex nature of digital skill and determine the boundary condition of social process. That brings us to the end of presentation. Thank you very much, and I am happy now to take your question.
Yeah, hello, nice presentation. Please tell me what policy implications arise from your research. Hello, am I audible?
Yes.
What policy implications arise from your research? Can you please explain? Hello, can you hear me?
Yeah.
Yeah, I just want to know that what policy implications arise from your research.
You can probably type the question in the chat as well. So.
My another question is, have you compared your research work with the state of art research or existing research works? Can you explain something on that? Am I audible?
Yes, ma'am. Duong Bui, ma'am, if you can hear, ma'am, please answer her question now.
by strategically digital technology and fostering a culture of continuous improvement, and leaders can enable their organization to navigate the challenge of the digital era to secure sustainable competitive advantage.
How many research papers you have taken for your research from recent years? Thank you so much from my
Sorry,
side.
it's
It's okay.
clouded here.
Sir, any questions for ma'am? Kehinde sir, do you have any questions?
No, no. I think let's just thank our speaker. And then yeah, we can move to the next speaker. So thanks very much for your presentation, Dimple.
Okay, thank you. Next, I would like to call Gomez Torres Esteban sir to present their study on unifying multi-cloud services in context-aware mobile apps, a CAMS F-based approach with fiber-based AWS and Azure.
Thank you. I'm going to show my screen. Okay. Well, this paper is Unify Multi-Cloud Services in Context-Aware Mobile Apps. Authors represent to University of Army Forces in Ecuador. We are very pleased to be in International Conference on Machine and Computing Technologies for Sustainable Development. Our agenda is problem context, limitations of original CAMS-F. I'm going to explain what's CAMS. CAMS-F multi-cloud proposed solution, architecture overview, code generation, infrastructure as code, case of study, results, conclusion, and future work. Context-aware mobile systems require flexibility. What is context? On the definition is any situation such as the location, but context includes several concepts. So we have been developing camps for several years, and this topic now presents different growing for global context-aware mobile applications. CAMSEF is a multi-cloud extends from original framework with a vendor-agnostic multi-cloud. We have conceived DSL and a multi-cloud development support. It enables a declarative selection of service across Firebase, Azure, and Amazon Web Services with automatic Flutter code and infrastructure generation. A logistic case shows improved regional performance and reduce vendor lock. So, there is a growing demand for global context-aware mobile application that must adapt to user location, environment, and regulations. However, deploy these apps globally introduces major challenges, especially in latency, governance, and regulatory compliance. Traditional approaches tightly couple applications to single cloud provider. This vendor lock becomes a critical barrier on applications that require region-specific performance and compliance, such as logistics, smart cities, and healthcare. With this brief introduction, we have to explain that original camps that we have conceived was introduced camps F, a model-driven approach for context-aware mobile applications. It is tightly coupled to Firebase ecosystem. This is one of the problems. But this limits multi-cloud support, making it difficult to select providers based on region, performance, or cost. As a result, compliance with regulations such as GDPR and region-specific routing are not natively supported, reducing scalability and resilience in global deployments. To overcome these limitations, the original camps, we propose camps F multi-cloud. This is our proposal. The solution introduced a vendor agnostic DSL. So we have to modify the DSL that allows the developers to declarative select cloud services per provider. Based on this model, the framework automatically generates provider-specific Flutter code, and we use infrastructure as code using Terraform, Pulumi, etc. And we can deploy in, for example, Amazon Web Services, Azure, or Google Cloud Platform, reducing vendor lock-in while improving regional performance and compliance. So, architecture. We have several layers. The first layer is declarative multi-cloud. The second is generation layer. The third is runtime dispatchers. And the last one is infrastructure as cloud development layer. So, CAMSDEV multi-cloud uses a layer architecture. A vendor-agnostic DSL defines clouds on context policies. The generation layer produces a specific Flutter code. A runtime dispatcher service based on policy and infrastructure as code layer automates multi-cloud provisioning with Terraform and Pulumi. So, our approach is based on extend and Axeleo templates, generate Dart service classes, and modular SDK wrappers for Azure, Amazon Web Services, and Firebase. And dispatcher selects provider and runtime based on region. So CAMS F multi-cloud uses extend and Axeleo templates, generate modular Dart for each cloud provider. At runtime, a dispatcher selects the appropriate provider on region or policy. Okay. Infrastructure as code. CAMS multi-cloud uses infrastructure as code to automate deployments across cloud providers. Terraform modules are generated per region and provider, while Pulumi enables full stack provisioning when more flexibility is required. These deployments are validated through CI/CD pipelines, ensuring consistency, reproducible, and region-aware multi-cloud setups. We validate CAMSEF multi-cloud with a cross-region logistics application in Europe. So the uses of Azure Map and Azure Notification Hub, while in the USA, it relies Amazon Web Service location and Amazon Web Service SNAs. Firebase, Firestore, and Firebase Cloud Messaging are used globally for data storage and cross-region notifications. This regional routing achieves an average latencies of 1.5 seconds and demonstrate improved performance and flexibility through multi-cloud deployment. The evaluation shows a multi-cloud achieves an 85% code reuse regions while significantly reducing latency through regional service routing. The hybrid cloud model lowers operational costs, combining free tier and automate provision.
Excuse me, sir.
Conclusion. Yes.
Gentle reminder that you've crossed your 10-minute mark.
Yes, though 2 minutes and
Yes, sir.
so CAMS multi-cloud reduces vendor lock, improves performance and compliance, enhances productivity with declarative modeling, and scalable, portable, and resilient architecture. Future work. In conclusion, CAMS multi-cloud reduces vendor lock by introducing a vendor agnostic and multi-cloud, and overall, we are going to extend to dynamic provider switching, edge, the use of edge computing, and SA pricing conditions. We also aim to integrate Edge Online and SLA aware services. Thank you very much. If you have need to contact me, you have over here my contact, my email, and I'm ready to answer questions.
Shalini ma'am, any questions for sir? Plainly, sir, any questions for sir?
Yeah, one quick question from me. So you said you use a CI/CD. Did you use Azure DevOps for that?
Well, exactly. We use the concepts of DevOps, but in the next generation, instead of DevOps, we are going to use multi-agents. So we are thinking in improving by using machine learning and intelligent agents in order to improve the deployment in cloud. Okay.
All right. Thank you. Any other question for our presenter?
Hello.
I want to
Yeah.
ask, how is latency managed when switching between clouds?
The switching between clouds is, as I have told you, is using CI/CD pipelines with Pulumi, because we use Terraform models that are generated per region, for Europe, for America, and for other Asia, for example. These deployments are validated by CI/CD pipelines, ensuring consistency, reproducibility, and region-aware multi-cloud setups.
My another question is, could the framework be adapted to edge cloud hybrid architecture?
The cloud architecture is defined over here in DSL, and in base of DSL with Axeleo templates, we define Dart service classes, and we include in this context templates to automatically generate modular Dart service wrappers for each cloud provider.
Okay,
Okay,
thank you. Thank you.
thank you very much.
Let's. I don't know if anybody has got any other question, but in the absence of additional question, let's thank our speaker for the wonderful presentation.
Okay, well, thank you very much for your time.
Yeah, thank you. Do you know if there is any other author online?
I would like to give one last call to the authors that weren't present today. Vijaya Lakshmi ma'am, R. Ranjani, Rehan Patel, and Sachin Divakar. I repeat, Vijaya Lakshmi, R. Ranjani, Rehan Patel, or Sachin Divakar. I would wait 30 seconds. If they do not show up, then I would like to continue with the concluding remarks. All right, sir, shall I proceed with the conclusion?
Yeah, sure. I mean, if the authors are not present, then yeah.
Okay. I sincerely thank our authors and their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. We, on behalf of the whole team, thank you for the support during this version of the conference. We will be happy to have you in the next version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months, so kindly cooperate with the team of MCT4SD 2025. I would also like to thank our session chairs, Dr. Professor Kehinde Oe sir, for chairing this session. I'm sharing a token of appreciation on behalf of the whole team and would request you to share any concluding remark you may have for the presenters.
Yeah, thanks very much. So yeah, I mean, it's been wonderful listening to the various presenters talk on some of the advances made in the field of computing technologies for sustainable development. I have learned a lot in this last 1 hour, and I believe everyone has learned a lot. So um, hopefully I can see all of you again in the next version of this conference next year. So thanks very much once again, and then yeah, see you next year. Yeah.
Thank you, sir. I would also like to thank Dr. Shalini Puri, ma'am, for chairing this session. Thank you for your valuable presence, ma'am. I'm sharing a token of appreciation on behalf of the team. Please share any concluding remark you may have for us.
Yeah, thank you for the invitation. And I sincerely thank all the presenters for keeping to time and for sharing high quality research. I also appreciate the audience for your engagement and thoughtful questions. So I encourage all the authors to continue these collaborations and discussions beyond the sessions. Thank you very much for invitation, and this was a really wonderful session. Thank you so much.
Thank you, ma'am.
Yeah.
I kindly request everyone to switch on their camera for a quick snapshot of the virtual conference. Everyone, please turn on your cameras. All right, thank you, everyone. Have a great day ahead. Thank you.